So now we want to talk about the classification of matter. And in our classification scheme, the periodic table is going to become a very important component of that discussion. So we can have substances that are going to be classified as pure substances or as mixtures. So a pure substance is going to be a substance that has a uniform chemical composition throughout its structure. So if we have a glass of pure water with nothing else mixed in there, this would be the example of a pure substance. However, even the water that you have in bottled water usually is a mixture. It's a blend of two or more substances, each of which retains its chemical identity. So in the bottled water, we often mix back in minerals that give the water a pleasant taste that we like to drink. And so our water that's actually bottled water, or the water that goes through those pure filters, usually is a mixture that comes out. So of the mixtures, you can have two types. You can have a homogeneous mixture. This is going to be a uniform mixture that has the same composition throughout. So the water in our water bottle would be a good example of a homogeneous mixture. There's some minerals in there, but we can't physically see them or detect them as being different from the water that's in there. And so it looks like one nice homogeneous mixture. It looks like the same thing. So homo means the same. A heterogeneous mixture, however, is a non-uniform mixture that has regions that have different compositions to them. So a good example of a heterogeneous mixture would be a bowl of soup. So if you think of a bowl of soup, it's got a bunch of different things in there and it makes it look very different. So oftentimes you'll have the broth, and that will look like a homogeneous mixture, right? It all looks like the same texture and same composition. But then you'll have noodles stuck in there, and you'll have the chicken, and you might have some vegetables. So you can tell that this is a heterogeneous mixture. It's got different components that you can visibly see are different. So it's a non-uniform mixture. So our components of a mixture then can be separated without changing their identities. So if we were to take our soup, for example, we could pull out all the noodles and we could put them in one place, and they're all still noodles. We haven't changed their composition at all. And then if we took out all the chicken would all still be chicken. We haven't changed it at all. So the same thing would happen if we took the water that we have and we evaporate the water off. All the minerals that are still in there have not changed in their identity. So if we have some salt in there, for example, some sodium chloride, if we take out the water, the sodium chloride is still the same. It hasn't changed at all. So that would be a good example of a mixture, because you're not changing the compounds themselves. You're just mixing them together into a blend, but you haven't chemically altered them. So this is a physical property. It's not a chemical change that's going on. So our pure substances then that we talked about can be classified into two major groups. You can have elements, or you can have mixtures of elements that are called chemical compounds. So an element then is a fundamental substance that cannot be broken down chemically into any simpler substance that is going to exist on the earth naturally. A chemical compound, on the other hand, is a pure substance that can be broken down into simpler substances by chemical reactions. And this is where we actually need to shift and just take a look at the periodic table. So if you look on the website, there is a copy of this periodic table that is posted in there. I would ask that each of you actually print this out. In fact, there's a couple of different versions of our periodic table that are posted in the class. You should print all of these out and keep them in your notebook, because you will utilize these over and over again within the class. The periodic table is kind of like the Bible for chemists. So it has all of this information that's stored in the organization of our elements. So remember, we said the elements are the fundamental units on the earth that cannot be broken down into smaller units, whereas our compounds are going to be mixtures of elements that can ultimately be broken down into their elemental forms. So we're going to spend a lot of time talking about the elements. All of the elements that are found on the Earth are located here in the periodic table of the elements. And so we will start defining what our elements are. You guys will be responsible for knowing the letter codes of the first 4 rows of the periodic table. So you'll need to know that He stands for helium, Ne stands for neon, Ar stands for argon. So you guys should start learning these. You may have some questions about them in the next class on Thursday. You also need to know some of them in the lower part of the table, and I'll point these out now because these happen to be in our environment quite a lot, and you'll see them in the news, and so you should be aware of these different compounds as well. Hg is one of them. This is mercury. So we will touch on some of the properties of mercury in this class and talk about how it is a toxic molecule. Pb is lead. It is also a toxic element that we find in the environment as well. So it's something that you should also be aware of. Au, over here right next to Hg, is gold. And we all know that that's a precious metal. And then over here, you should know iodine. As this is important for biologic systems, we all need a little bit of iodine to function properly, and so that's a key mineral that's required for the body. So outside of those guys, most of the major elements that are found on the Earth can be found in the first 4 rows and are the major things that we will see within the environment. Some of our additional metals down in this row. Oh, the one other one that you will need to know is silver, which is Ag. So you should know silver and gold. They're right here next to each other. So you should know that one as well. Okay, so that's a brief introduction to the periodic table of the elements. The elements are not broken down into further smaller components naturally on the Earth. So scientists are playing around with the different elements, and we have been able to break them down further in the laboratory. But this is not a natural occurrence, and so we still say that the elemental forms are the base substances for all of the different compounds on the Earth. So when we're talking about chemical reactions that can form different compounds, we can write that as a statement. So we can chemically say that if we break down water, which is H2O, so if we look at our periodic table again, we'll see that H2O contains 2 atoms of hydrogen, 1 atom of oxygen that mix together to form a compound. So again, compounds are going to be mixtures of the different elements as they come together. And we're going to spend a lot of time learning the properties of our different elements to show how they like to bond together and form these bigger compounds. So when we do this, when we're looking at chemical reactions that are going to change the elemental forms of compounds, we can write it as a statement where we actually write out the different components of this. So we can say water will react with an electric current, and it can get broken down then into its elemental forms. It can get broken down into hydrogen and oxygen. So when we write a chemical reaction, we would say that the stuff we start with, that's always going to be presented on the left-hand side of the equation, is called the reactants. So in this case, the stuff we start with is the water. This is going to be our reactant. So it's going to undergo the reaction with the electric current. So the reaction is actually indicated by this arrow. So that's indicating this activity is going on with the help of the electric current. And then we're going to get products out on the right-hand side, and they will be on the right-hand side of the arrow. In this case, the 2 products that we're left with are going to be hydrogen and oxygen. So I think we'll stop there for this first section, and next time we will talk a little bit more about the periodic table and give you a brief introduction to some of the different major elements and their groupings on the periodic table.